is f of x plus f prime of x, x minus a. I'm sorry, of course. F of a plus f prime of a times x minus a. So this is 0. So I have to find f of 0. I have to find f prime of 0 and multiply by x. So this will be our linearization. Is this okay so far? Is that a yes or a no?
Yes.
Okay. So let's find the derivative. So we know that f prime of x will be 1 over 2, the square root of 4 minus x multiplied by the inner function prime. So when I determine f prime of 0, I have 4 minus 0, which is 2. 2 times 2 is 4, but I have negative 1/4. And f of 0 right here will be 4 minus 0 is 4. The square root of 4 is 2. Now I will put everything together. So the line that approximates the function given to us around 0, near 0, is f of 0, which is 2, minus x divided by 4. So now I have to plug in 3.9 and 3.99 and use 4 decimal places. So I'm sharing my screen, and now I'm here, and y equals, clear, and what do I have? I have 2 minus, I'm going to write 0.25x. Okay, so then I have plug it in, and I get 3.9, and then 3.99. Which I disagree with, to be honest. Well, actually, it is close to 4. So a is 0. Yeah. Sorry. So then I have to write for the first one 1.025. They want 4 decimal places. Let me visualize the second one carefully. Okay, yeah. So the other one is 1.0025. Okay, and oh, I didn't mean to do that at all. I meant this. Okay, so right? So you can also check if you have any doubts. You can plug in the calculator square root of 3.9, and you should get something very close to 1.025, and you can do that. So I'm doing it with the calculator because I don't want to switch again over there. So 3.9, I will. So 1.0025, we should expect some error. There must be. I'm not using the function, I'm using the approximation, which is the linear approximation. And then the square root of 3.99, the actual is this, and we have a minor error, as expected, because as I said, we are not using the function. Okay, so do you want me to graph this? Or was the graph okay? Okay, let's graph. Since I didn't, oh, why am I doing that all the time? Okay, so in y equals, I will put the second function as the square root of 4 minus x. Close the parenthesis. And now I want to use a window, and I only care about what happens around 0. So I'm going to say between -3 and 3. I don't know how high y should be, but definitely not below 0 because it's a square root. So obviously, and when x is 0, y is 2. So not more than, let's say, 4. Let's see what happens. Here it is. Okay, we can zoom out if you want to see more. And zoom out is 3. So obviously when x is 4, y is 0. So when I go back to the graphs, I don't like picking and choosing. This is a candidate. This is not. This is not. This is not. I don't like choosing like that, but obviously it's this because the square root of 4 minus x has the x-intercept at 4 and the y-intercept at 2. This one has 9. No question there, right? 16 and 1 makes no sense. So any questions about problem 3? Anyone? Does anyone want to say?
Real quick, so maybe I'm just overthinking this. This is where I had a problem in it, is what would you put in at the top of question 3 for LX?
For LX?
Yeah, at the top.
What do you mean?
Like, what would you put? Would you just put the
We
2
just-
minus
we
x
just-
over 4?
We just determined that.
Okay.
That's a linearization.
All right, I was just wondering if, so you just put in the 2 minus, okay, yeah, I was just overthinking it. I'm sorry.
No worries, but that's why we wrote. So
Okay.
that's why that's a very good point. That's why I never write something like this. If I write something like this, it's obviously wrong. I mean, what am I presenting here? But if I write the linearization of x is 2 minus x over 4, this is very clear.
All right, thank you.
Is that okay?
Yeah.
Perfect. So now let's look at 4. So do we still need 4?
I was getting a weird answer
Sure,
for it. I followed
let's
the
do it.
instructions that they
Absolutely.
gave for us. Again,
Absolutely.
it was mainly just a problem of like, I was probably doing something wrong and didn't know what I was doing wrong.
Is this problem okay? You want me to do work on your own?
Yeah, that one's okay.
This one is okay. Okay. So we have again a equals 0, so everything is the same. So we still have L of x, which is f of 0 plus f prime of 0 times x minus 0. So I have to find f of 0. So when I put in 0 here, can anyone tell us how much is natural log 1?
Zero.
Thank you very much. Very good. So can anyone give us the derivative for that?
1 over 1 plus x.
Excellent. Times the inner function prime, which is?
1.
Excellent. That's it. So then let's find also f prime of 0. Can anyone give us f prime of 0?
One.
Thank you very much. So now I can find the linearization. F of 0 is 0. F prime is 1 times x. So this is basically x. Anything else? Other questions? Anything? Is this okay?
Yes, thank you.
Thank you. Is there any other part? Maybe there is another part that I didn't notice here.
No,
Okay.
I just did the 0 and the 1 backwards, so I kept getting 0 for some reason.
Oh, okay. It happens. Good. Yes, ready?
In the same one, the same 3 point, this is 3.10.
Correct, yes.
Could you do 12?
Yes, of course. Okay. Is this a problem that you want, or you want me to work on your number?
It's pretty close to mine. It's virtually the same.
Okay, so you're okay with this one then?
Yes, this is good.
Okay. So remember, we had several examples like this. So please, that's why my hope is always that my students will go back. I meant to write dx. So this is, I meant to write here dy. So this is dx. So that's my hope, that my students always, before they do anything, they redo the problems we do in class. It will save you a lot of grief. So all I have to do is identify x, f of x, f prime of x, and dx. Any questions? Can anyone help?
Is X 100?
Right? So we did a trig function one last time, and we had a couple of examples prior. Yes. So what is f or x? Well, whatever you want to tell me. I'll accept anything.
X is 100.
Very good. Awesome.
Is DX 0.6 or negative?
That's it. Good.
So F is, 10? No.
Just read this. When you read this, you'll know what the function is. Just you only have to read it.
This is the square root, so the function is square root of X.
Good. That's all you have to do. You don't have to think. Just read it.
Okay.
Good. And f prime?
1 over 2x. No. 2 times the square root of x?
Excellent. Good. So that's all I have to do. F of x. Can anyone give us f of x with the x being 100? Good. Plus, can anyone give us f prime of x with x being 100?
1 over 10.
Very good. And dx, I can copy it myself. And that's it. So then I have 10 minus, I have 60 over 200 because I have to simplify it. I will simplify it again. So I have to multiply by 10. Okay, I didn't mean to do that. Of course, I multiply by 10 and I get 6. I multiply by 10, I get 200. But I can simplify by 2. So I have 3 over 100. That I can do. So then 100 times 10 will be 10. It will be 1,000 and minus 3 at the top divided by 100. You don't have to do anything else, but just write 997 over 100. Okay, so I'm checking my numbers because I made a tiny error here and I realized what was happening. So 10, I multiply the top as it's minus. I multiply the top by 10, the bottom by 10. So I have 6 over 200. I simplify by 2 and I get 3. I simplify by 2 and I get 100. Then I have to multiply by this because I have to find the least common denominator. So 1,000 minus 3 will be 997 over 100. So this is it. You don't have to approximate it. I want to approximate it just for my own checking, right? I need to check just to make sure that I didn't make an error. But I don't have to approximate it. This is it. So we are comparing the square root of 99.4. Oops, what was that? And 997, which I know what it is 9.97. I don't have to approximate that, but let's see it. 997 divided by 100, and let's see where. Okay, so I have 9, and then 6, 7, 6, 9, it's 7. So this is our approximation. This is the exact. Good. So we know that what this is, right? 9.97 because I'm divided by 100. That's all I need to show. That I use the line to approximate the square root, basically. Good question. Anything else? Is there anything else we need to work on? Anything? That's why I want you to finish the homework so you can ask any questions you may have. Anything. Which type of problem you would like to work on? which type of problem you'll say, if I see this on the test, it will take me a long time. I will probably have difficulties with it, or I just want to see another one. Period.